Okay. Wait just a minute for some more folks to join here. Okay. We had like 5 or 6 people, different connections, so I'll wait just another few seconds. Okay, hopefully they can catch up. So all right, so yeah, IEEE has a large standards organization process and very formalized, and you can find out information about it here. Um, and these points here are taken from that website that I was just talking about here. So let me um, go back there to IEEE. So um, they they define their standardization process in 6 different stages, talking about how do you start a standards process or project. And you're basically going to come up with a project abstract, or project approval request, basically a PAR. I'm not exactly sure what that stands for, but yeah, if there's enough interest, you write a request, and you might form a study group, and then um, you find a sponsor for that standards process. That might be, let's say, the Communications Society of IEEE, or it could be one of the other societies, or it could be another part of IEEE, but it needs ultimately needs to be sponsored by someone. So, like I say, the Communications Society, or let's say the Computer Society, those are very typical choices to sponsor that. And so then you eventually get approval. So there's a little timing of this from when you start studying it, forming a study group, and working on it. So like their study groups here are what you might do while you're in that um, you know proposal process before it gets fully kicked off, right? And so this is an example of the study group guidelines. It is somewhat formalized just to make sure that things are fair, and that everyone has an appropriate voice in the system. Some standards processes have kind of gone off the rails and had some problems, and the standards need to be withdrawn because they're found to be unfair, that type of thing. So then eventually you form a working group, and as an engineer, yeah, you can jump on a working group. These guys meet several times a year, and so there's a bit of a soft commitment to that. Don't join a working group if you're not going to be able to participate, but they tend to be, these meetings either tend to be virtual or co-located with big conferences, like for the Communications Society, our big flagship conference each year is Comm. I've got a number of other big conferences that are spaced throughout the year, but Comm tends to be towards the end of the year, and so there'll be lots of different study or working groups, either the day before or the day after the conference, and that type of thing, right? So then there's ultimately drafting the standard, where you write it out and you work with an editor at the IEEE to deal with that. We'll look at some standards here in a minute. Then there's the voting process, and then we'll look at that here in detail. And then final approval, and then yeah, so even after you have final approval, you might want to revise that to add some new technology, or you might find that there are some errors in it, and so there's a process to maintain those standards going forward. So I kind of highlighted some of those points here, but I encourage you to go to the site and kind of browse through each, click through each of those links. There are short descriptions behind each one, so it might take you an hour to kind of study that. And so I'd like to probably draw some test questions for the final exam from some of that. But this is what I would kind of emphasize. So initiating the project. Okay, yeah. So the PAR stands is short for Project Authorization Request, and identifying that standards committee and possibly forming a study group in advance of mobilizing the working group. So it's intended to be an open process, not trying to close it off and exclude different constituents or stakeholders from it. It's intended to be an open process where meetings are announced with agendas and minutes are published of those meetings and that type of thing. So this operations of the working group is governed by the IEEE Standards Association Standards Board bylaws, their operation manual, standards committee policies and procedures, and a working group's policies and procedures. So again, trying to make sure that standards are developed in a fair process, and we publish the agendas and the meeting minutes. So that whole process might go on for a few years as the working group looks at what needs to go into a standard, how do we establish a technology, and how do we document it, what needs to be documented so that the standard is complete. And again, most standards, kind of the big motivation for using a standard is to ensure interoperability. Well, if you aren't comprehensive enough in your standard document, then someone might choose to implement it one way, someone else might choose to implement it a different way, and that could lead to some incompatibilities, and we don't want that. We want the compatible operation. So you need to be thorough in that. So we're not only deciding what needs to go into that standard, what's the best way of creating a waveform, let's say, how many different options should there be, and that type of thing, but also to make sure that it's thoroughly documented. Ultimately, so then it's drafted, and then it needs to be voted on or balloted. So and this is kind of the other key part. So you might involve in doing this, developing the standard for quite some time, and then drafting it is tedious but necessary process, and then we ballot it. So the idea now will form a balloting group. So that may include others that were not part of the working group. Maybe not everyone in the working group is in the balloting group, typically, but not necessarily, right? And so the balloting group is designed in order to reflect a diverse set of interest categories, right? So vendors, users, different parts of the world, that type of thing, trying to create a balloting group that reflects a diverse set of interest categories. The ballot goes out, and to count, basically, so there's some more rules, but these are kind of the essence of it, that it's not a majority rules, it's a consensus type thing, right? So we want to get as many stakeholders in agreement on this as possible. So your vote could be yay or nay, to approve or disapprove, or to abstain, right? And so the measure of consensus is that out of that balloting group, 75% of the ballots are actually returned. And of those that are returned, at least 75% are voted for approval. So simultaneously, you can, as a member of the balloting group or as a member of the public, you can submit comments and on the standard, and the working group is intends to respond to all of those comments, and so all comments are addressed. This process takes 30 to 60 days. That's not a lot of time, considering some of these standards can be quite complex, and hundreds or even 1,000 pages long in some cases. So it's a lot of work. And so then assuming we get past that stage, then there's still a final approval by the IEEE Standards Association Standards Board. And they vote after recommendation of the Standards Review Committee. So lots of bureaucracy, but the bureaucracy is there to make sure that, again, it's a fair and open process. And so at that level, it's less about, hey, does this technology really work and that type of thing, but more of were all the procedures properly followed, and the guiding principles, of this open and diverse type of process followed. And then, as I say, there's maintaining that standard. All right, so in addition to the standards organizations, there's a number of advocacy organizations that you might run into. These tend to, influence, let's say, regulatory agencies or standards organizations, or the government itself, Congress, or to promote their membership to the media and to others, right? So CTIA is kind of the biggest for cell phone type technology. It has stood for these acronyms. These letters have stood for different things over the years. It used to be I think Cellular Telecommunications Industry Association, but then when the internet became big, they decided the I should stand for the internet, but these days it just stands for CTIA. So it doesn't stand for anything, but they actually have a very large expo and conference each year, and and like the times I've gone there, like CNBC has been broadcasting live from the floor of the symposium, so it's a really big event. The WIF is an organization I've been involved with, Wireless Innovation Forum, the Dynamic Spectrum Alliance. A friend of mine is the president of that, and they're focused international organization that's focused on technology techniques to be able to use spectrum dynamically, as opposed to fixed allocations that aren't necessarily the most efficient way of doing that. And then there's ADIS. If you want to become a member of 3GPP, then you would actually go through one of the organizations that's local to your country. And ADIS, there's actually a number of different organizations that had the same acronym, but the Alliance for Telecommunications Industry Solutions. So there's a ton more, lots and lots more, but just these are some of the big ones. And just to know that, yeah, there's standards organizations out there, and then there's advocacy type organizations that provide a lot of value to the practicing engineer and researcher in the field. All right, before we go on to research trends, let's look at some of these standards. So here, let's look at some 5G standards from 3GPP, so you get an idea. So here's kind of an overview document. So here we're looking at this transform pre-coding. Subcarrier mapping is when, if you remember in the OFDM, we've got maybe a few thousand different subcarriers, and you might map a number of those to a particular user, and you may decide that those subcarriers are going to be modulated at 16 QAM, let's say, or 64 QAM, or something like that, right? So, and then there's that inverse fast Fourier transform and inverse discrete Fourier transform that actually creates the OFDM waveform from these subcarriers. Not shown here is the parallel to serial conversion step, but that's kind of a trivial step. And then the cyclic prefix insertion, right? So here's the some of the different ways you could do that. So this is a subcarrier spacing, 15 kilohertz, 30, and we talked about how that's can be a power of 2 related to 15 kilohertz. And there's both a normal and an extended cyclic prefix and so on. So again, this is more of an overview document. Let me show you how tedious and detailed some of these documents can be. Whoops, did I lose it?
Yes, I'm here. I don't remember when I sent them in. I just know you guys received it on April 18th because that's what the tracking ID says.
Emily, I think you've got an open mic right now. So
Yeah, no problem. Give me 1 second.
okay. Just want you to understand that you're public right now. So okay, so like here's a
Yeah, see, that's the other thing. Now that I'm looking back at it, it says like, let's say
Emily, oh, here you go.
I just
All right, we're all good now.
I just muted her, so I realized I forgot I could do that. So yeah, so here's just a random table in this standards document. It's talking about some of the channel coding. It will give you these kind of algorithms and tables and equations and that type of thing. Sorry, my computer is not being very responsive. Let me so let me I'll jump around here a little bit. So so here's the wireless innovation forum home and stuff. So and so you see the WIN forum members are dedicated to advancing technologies, supporting the innovative utilization of spectrum and development of wireless communication systems. So and then there's the CTIA. That's that big organization. And so they're advocates for legislative or regulatory policies. They convenes the industry and conferences and working groups and that type of thing, and then advocates their members. So and let's go to their homepage here. So yeah, you'll see them involved in all sorts of different kind of promotional type of things here. And then Dynamic Spectrum Alliance. Again, this is some big companies, and then international observers, all sorts of different constituents throughout the world that are involved in this organization. Let me go ahead and out. Before I close all these out, so if you wanted to get some of these standards, for example, well, Bluetooth, here's that specification. I downloaded that. The 3GPP, we can go and say, all right, so I'm interested in the radio aspects. So some standards are kind of simple enough to be handled in one or a small handful of documents. 3GPP has just an outrageous number of different documents, and just trying to get to the right one can be quite difficult. But here's an example. You might look at oh, that's really old. Base station, is that one? Yeah, so this one's still a viable 104. I think I actually have it downloaded. So you can click on that, you find the standard you're interested in, and you go here and you'll get a little bit of information. So this is saying that this applies to 3G, so it's an older type standard, but you can look at the different versions, and you can pick a particular version, and you'll see that it's this version was associated with a particular meeting, and so you could click on this link to show your meeting details. And so I don't have access to all of it, but you get a little bit of information here, and if you are a member, then you would be able to download all sorts of information associated with that, right? So but then if you want to download something, then you can just click on that particular version. And so all these are under version control, so you can go back and look at the original ones and previous versions and that type of thing. So let me just kind of close out some stuff here, so my computer might be a little bit more responsive. So again, this is a particular technical specification for the 3GPP, third generation. Well, again, this is the type of thing that this acronym has changed over time. It used to mean one thing and now means something else, and so I don't even know what it means anymore. But this particular standard is in section 38, and this is the particular standard. So 212 in the family of standards 38, and this is the version 17.5.0, and it's effective date of March 2023. So and then this one's talking about the new radio, which is kind of the physical layer radio that we talk about with 5G. It's new. How long will it be new? I don't know. So I never name your thing new, because eventually it's not new, right? But and this one is in particular focused on multiplexing and channel coding. So if we scroll down here, you'll see some boilerplate types of stuff, some copyright, then the content. So here we're going to have some scope and references, definitions, And then we get into the meat of the standard, right? So mapping to physical channels on the uplink, the downlink, and any side link type of control type information, right? And then we have the general procedures. CRC is a cyclic redundancy check, and that's a simplified way of doing error checking. And then we've got polar coding and low density parity check coding, which would be like very advanced type coding techniques relative to our linear block codes that we studied and convolutional codes, and they tend to take an iterative process to decode. And so you're looking at channel coding. We didn't really talk about rate matching, so I'll just hand wave over that. But yeah, so you can get an idea of these standards here and how extensive they are. Okay. Let me look at a few others here. And here's another one. I think this is kind of the base station one, but it's talking about all the different frequencies that have been allocated by some government organization somewhere, and now we're going to name these as operating bands, right? So like here's one, 703 to 748 megahertz, and we're going to designate that as N28, just a shorthand, right? And that's the uplink. So this is using frequency division duplexing, which means that the uplink is on a different frequency than the downlink, right? So the uplink again is from the transmitting from the user equipment or subscriber equipment. That's your cell phone, right? Or your whatever is my Tesla car has an LTE radio in it, so it's not just cell phones. But so you're transmitting from the subscriber unit or the user equipment up to the base station in this band, and then the downlink from the base station to the user equipment is on this different channel. So this allows you to be able to be sending data up to the base station simultaneously while the base station is sending data to the user equipment, right? So that's in contrast to like a time division or duplexing type situation. Oh God. Yeah, totally lost that. I was trying to adjust it. Well, sorry, I've lost that table. But the time division duplexing operates on a single channel, single band. And so your downlink and your uplink are on the same frequency, and they are instead of talking at the same time, you take turns, right? So you divide up a time period and say for so many frames, you're going to be focused on the uplink, and then you're going to switch around and do the downlink. Typically, we talked about symbols, slots, and subframes and frames last week, I think. And so you would tend to send one frame on downlink and another frame on uplink, and there'd be timing criteria in between those. All right, so that's kind of a sampling of those. So let's see if there's anything else I want to close that out and close that out. Okay, so and so Bluetooth and IEEE type things will have standards documents that they're very similar. So just giving you a flavor for what's in there. They're not easy reading, but they're very precise and comprehensive. All right, so let's spend the last 10 minutes looking at some research trends. So while we're still implementing 5G, we're starting to talk about 6G, and there's not really any surprises here, huge changes yet. But one of the things that is expected to drive some of the 6G use cases are more of an immersive environment. You can think of the metaverse, that type of thing, augmented reality type of things, and an extension of the Internet of Things, right? So big part of 5G was addressing the Internet of Things and being able to scale out to very low cost, but many thousands of machine-to-machine type communication sensors and actuators and that type of thing. There's important challenges and like industrial control systems and that type of thing. So and in particular kind of security and also the reliability and the latency associated with that. So all that's in 5G, but now 6G will be that on steroids. So like 6G is looking for more of a 2030 type rollout. So it's years off. Might happen sooner, might happen later. So one of the interesting things I mentioned IoT, Internet of Things. The idea is that we're going to put sensors and actuators everywhere, particularly sensors, and more, and we're seeing that. Your smart home has lots of sensors, and everything's getting sensorized now, right? We're collecting tons and tons of data. There's always an issue of powering those things, right? Do you need to connect them to AC, or do they need to be battery powered? Can they be solar powered? One of the ways of doing this, and I worked a little bit on this back in the 80s, late 80s, early 90s with toll tags. But there's this technology that's really being investigated a lot lately is called ambient backscatter. So basically you're going to do it much like your toll tag works. You're going to put out a large burst of energy. That energy is going to power up a sensor tag type of system. It's going to make a measurement, and it's going to transmit that information back. And so there's lots of different ways of doing that and stuff. So that's a big area of research, and the main benefit there would be you don't have to power up your systems. They're powered based upon the energy that you're using to interrogate it with. Smart surfaces are top things where you might take some metamaterials and activate them or shape them in such a way to reflect radio waves, or to even to transmit them, refract them, that type of thing. You might do that to actually encode information, or you might do that to do some beamforming of the signal using smart surfaces. But really, we're a lot of the research is still is focused right now on implementing things. So there's always someone working on some new theory. But as it turns out, things like our error control coding, that's really approaching the Shannon limit with some of those LDPC codes and polar codes and turbo codes that are in 5G and even in 4G. We're approaching those limits that the Shannon capacity theorem says, yeah, you can get here but no farther, right? So, so a lot of the research is focused on implementing things. Nowadays, we're spectrum hungry, and so we're looking at millimeter wave frequencies for more spectrum, and so there's a lot of implementation type things there. So integrating with low Earth orbit satellite constellations. Of course, we're all familiar with Starlink, I would assume. Amazon has Project Kuiper that is not quite as mature, nearly as mature as Starlink, but they still have big hopes for it. And then there's some others. OneWeb, I think, is another one out there that's maybe not as good at the publicity game. But being able to directly integrate with your cell phone to these LEO satellite constellations is a big thing. And then dynamic spectrum access, being able to instead of having to be licensed all the time to use a particular spectrum, being able to access spectrum opportunistically. Didn't go into that a lot, but again, spectrum is a finite resource. There's only so much of it, and so we're trying to figure out how to make better and better use of that spectrum access. So then I also wrote up some trends in the DoD. They're a lot of times kind of behind the game these days, but in other areas they're ahead of the game. So in the DoD, we're not just concerned about communicating, but we're also concerned about how others communicate, right? And we may want to deny an adversary's communications, or they may be trying to deny our communications or spoof them or intercept them and eavesdrop on them. Not just communications, but radar. GPS is a form of communications. We're communicating position, navigation, and timing information from atomic clocks on satellites, basically. So yeah, so this is a listing of some of those, and we're out of time. So yeah, that was my last slide. So we'll do a semester review on Friday, and we'll see you then.
Thank you, Professor. Have a good one.
Take care.